All right, and we're back again for yet more chit chat on index laws. So we've already learnt that the shortcut for multiplication, only where I have the same base, is that a to the power of m times a to the power of n equals a to the power of m plus n, where I'm dividing with the same base. A to the power of m divided by a to the power of n equals a to the power of m minus n. And that rule took us on to the concept of anything to the power of 0. A to the power of 0, anything. A could be anything. The only thing a can't be is 0, because anything to the power of 0 equals 1. All right, now we're going to have a look at what happens when we're doing shortcuts with to the power of another power. This time, a to the power of m raised to the power of n means that the shortcut is am times n. We also need to remember here that everything inside the brackets needs to be raised to the power outside the brackets. So let's have a little look here. If we had two bases, we'd have to raise a to the power of m, cool, times b to the power of m. Same deal when we're dividing. When we're dividing, we have to raise a to the power of m divided by b to the power of m. Everything good? Excellent. Let's keep moving. So, let's do a couple of little examples as per usual, just to check that we're right, just to prove our point. So this time I'm going to say 3x to the power of 2, and I'm going to raise that whole thing to the power of 3. So everything inside the brackets needs to be raised to the power of 3. So it's 3 to the power of 3. Excuse me. Times x to the power of 2 times 3. Really, we know that that's 3 to the power of 1. Really, we know that that's 3 to the power of 3 times 1, or 1 times 3. So 3 times 3 is 9. 9 times 3 is 27 times x, 2 times 3 is to the power of 6. And we can simplify that further by getting rid of this. We don't include the multiplication, and that's our answer. Let's have a crack with division and more than one base. So I'm going to look at 4x squared, excuse me one more time. Sorry about that. Y to the power of 5. I'll divide that by 2. X to the power of 4. Y. And I'll put all of that in brackets. And whatever that answer is, I want to raise it to the power of 2. So let's go. I've got 4 to the power of 2. Coefficient first. On the top and on the bottom. 4 to the power of 2. You've been done. 2 to the power of 2. You've also been done. Again, remembering that really it's 1 times 2. Or 1 times this. 1 times this. Times x. 2 times 2. Yep. Again, apply it here. X. 4 times 2. Great. Times. Okay. Y. 5 times 2. Divided by, and remembering again, that's really y to the power of 1. Y. 1 times 2. All right, time to simplify. I know that 4 times itself is 16. 2 times itself is 4. Times, I'm going to use the little circle this time just to remind you that I can use either. I'd be consistent inside the same sum, however. Actually, I will be. That's a bad example. So x, 2 times 2 to the power of 4. 4 times 2, x to the power of 8 times y, 5 times 2, to the power of 10, over y, 1 times 2, to the power of 2. Okay, that's a 10. All right, time to simplify. 4 goes into itself once. It goes into 16 4 times. 4 over 1. Now I just apply my division rules. So I'm going to be left with 4 down the bottom. Cancelling it out, it's actually 4 minus 8, which leaves us with negative 4. And we'll see why that is later. But just for now, I know we're going to be left with 4 down the bottom. This one's gone. And this one's going to be x to the power of 4 times, and again, this one is going to be cancelled out, and it's going to be 10 take away 2, y 8. Let's simplify even further. 4 times 1 is 4 times y 8. 4 y to the power of 8. Divided by 1 times 4 to the power of 4. 1 times x to the power of 4 times 1 is still just x to the power of 4. So what's super important to remember here is multiplication, same base, mn, m plus n. Division, same base, mn, m minus n. And that proved to us that anything except for 0 to the power of 0, a to the power of 0, a can be anything except 0, is 1, and anything raised, so anything to the power raised to another power, a to the power of m, raised to the power of n, is the same as saying a m times n. And a quick reminder again, everything inside the brackets needs to be raised to the power outside the brackets. Excellent.